Rami here from Solar Juice, and we're at SNEC 2024. Here I have Thomas again with me from Aiko, and he's going to take us through some stress tests for the solar cell and the solar panel.
Yeah, thanks Rami. So what we see at SNEC that is different to Australian exhibitions is real-time testing of products. And that's something really unique, and we have some great things to show you here today. So the first thing we're going to show you is the impact test, and we also of course have a pressure test behind us. So what we're looking at here is what happens when we stress our cells mechanically. What is the performance of the back contact cell versus the standard type of solar cell? And that's what we're interested in here today. So we're going to be taking a standard 2 kilogram weight. We're going to drop that at 1 meter per second on both of the different cells, and we've got them connected electrically. So if you look at this cell here, we've specially developed electrical connections for them. We're going to look at the physical property of the cell after it's been tested, and we're going to look at the electrical output. And this just gives us an indication of the relative strength of the different technologies. Of course, we don't encourage you to drop weights onto your panels back in Australia, but it does give us a sense of how that panel is going to respond to things like impact from hail, things like stresses under cyclones and other conditions that you can't necessarily expect. So here we're doing the live test. We're inserting the original TopCon cell. So this is a TopCon cell. It's going to go automatically into the machine, and that machine will then drop that weight in a uniform way on both the cells. So you're going to... So now we see the cell after the testing. We're going to run an electrical test on that cell and just see how it compares the output of the cell from prior to testing to afterwards. So now we are seeing a loss of 44% of the original output of that cell following the stress. And we can see that it's quite fragmented as well after the test. So now we're inserting a back contact cell, one of the Aiko ABC cells. As we like to say at Aiko Australia, ABC, Australia's best cells. So what's different to historical back contact cells is that many of those were P-type back contact. This is an N-type back contact. So the front side or the bulk material of this cell is an N-type material. And on the rear side, we've scribed in P and N-type regions that we then attach metallization. So now the machine's going to insert itself automatically. It's going to replicate the test exactly the same with that 2 kilogram weight at 1 meter per second. Now let's look at the difference in the loss. So on the screen here, you're going to see a difference in the loss of current. Just waiting for the result there. So you can see the loss is much smaller at only 14% from that same impact. So we can see the relative strength of the back contact cell just from this small test here today. Now, of course, at Aiko head office, we're doing tests far beyond this. So we're testing the whole module in an R&D context. And then in the production context, of course, we are testing the wafers, the cells, the laminates before lamination, the laminates after lamination, and the panel after the junction boxes are added. You can see from this image that the cell is far more resilient than a traditional cell. So that's why we're confident that the back contact cells will work really well in our tough, harsh Australian conditions.